Before the show, a quick word from our sponsor.
Stacks 2.0, they're no longer block stacks. It's now the Stacks 2.0 blockchain. And they're really orienting around Bitcoin, right? So the whole idea is it's a blockchain. They have a proof of transfer, POX, and you peg in Bitcoin, and Bitcoin is the money on the blockchain. They also have a governance and staking token to support that blockchain, STX, but you don't need that token to use the blockchain. And that blockchain, it takes on a lot of the features that, you can't build directly into the Bitcoin blockchain, things that other altcoin chains are trying to do, and it brings it to a Bitcoin denominated world. So I think that the world is going to start denominating in Bitcoin, and the closer and more trustless you can get to using Bitcoin, the more people are going to want to use those applications. So it's exciting to see what Blockstacks is doing here and them committing to Bitcoin. We're starting to really see the narrative of Bitcoin, not blockchain. Like their marketing, their branding is all about, we are part of Bitcoin. We're leveraging the most important, the most prevalent blockchain, and Bitcoin is money on our blockchain. So I like that turn of directions. Go check out stacks2.com. So that's STACKS2, the number 2.com, and learn more especially if you're a developer. But if you want to just poke around and see their blockchain based decentralized apps and DeFi stuff, again, they're doing that all on the Stacks2 blockchain.
Live from Utrecht, this is the fan Wirdum Sjorsnado.
Hello.
Sjors, I heard Bitcoin is broken.
It is.
Again.
Yeah, it was absolutely terrible.
A double spend happened.
Yep, ruined.
And this is because a fatal flaw in the Bitcoin protocol.
Yep.
That's how it was reported, I think, in Bloomberg.
Yeah, I couldn't find the original report by Bloomberg. I think Cointelegraph reported it more or less in that way, and then Bloomberg referred to it.
Oh, yeah, I think that's what happened.
But at least more recent articles I saw from Bloomberg was saying, noobs thought it was broken and they were all Googling double spends.
Oh, they corrected it?
I wouldn't say corrected it. They were more like, going meta on it.
On their own mistake.
So I don't know if it was their own mistake, because I've only seen the haters basically saying that they made that mistake.
Fair enough. Okay, so to be clear, Bitcoin is not actually broken.
Nope. It's working as expected.
It's working exactly as expected. Now, we could get into a discussion on whether or not double spend happened or not, and that gets into the definition of double spend. But we're not going to do that, Sjors.
No.
Instead, we're going to explain what was sort of this alleged fatal flaw in the protocol, which was replaced by fee, RBF.
Yes.
That was sort of why this alleged double spend could have happened.
Yeah, it could have happened even without that, but...
Sure, yeah, and I guess that's the sort of stuff we're going to discuss in this great podcast today.
Exactly, so stay with us and you'll learn more.
Okay, first of all, Sjors, this thing is called replaced by fee. Just in brief terms, what does it mean? What is replaced by fee?
So it means you have a transaction that might be going from A to B and you're paying a fee to the miners, and you decide it's taking too long because miners will mine the biggest fee first, generally. And so you can send a new transaction with the same origin, same destination, if you like, and you increase the fee. And then that gets propagated to your peers.
Yeah. Well, now you've already sort of described the use case. If we want to put it in more abstract terms, it basically means that if there are conflicting transactions, the miner will pick the highest one, right?
Exactly. So conflicting transactions means spending the same input.
I said highest one. I mean highest, the transaction with the highest transaction fee.
Yes, that's right.
Yeah. So, and you just describe one use case. You're sending a transaction and it's taking too long to confirm. So you send a new transaction with a higher fee.
Yeah, and that's a very, reasonable use case. You're sending a transaction with maybe 1 Satoshi per byte because you're not in a hurry. But then after a couple of days, you're like, okay, this is ridiculous. And you bump it to 100 Satoshi per byte, and it goes in the next block.
Yeah, or after a month. Right now we have transactions in the mempool that have been there for a month that pay 1 Satoshi. This is the first time ever, I think, this has happened.
Okay.
So fee market is working, which, Sjors, is the next point I want to make. This is another argument in favor of replaced by fee, is that it actually allows for a more effective fee market to happen.
Yeah, that's right. Because in 2017, what we saw is that because people did not use replace by fee, they saw the mempool was quite full, They thought, okay, currently the fees might be 50 Satoshi per byte, but I can't change it anymore, so I'm just going to be safe, and I'm going to set it to 100 Satoshi per byte. And then the next person would say, oh, well, that looks really expensive. Let's make it 200 Satoshi per byte. So people were really bidding up against each other much more than was necessary.
Exactly. With replaced by fee, they could have instead paid, say, 1 Satoshi, and then keep an eye on the mempool maybe and see, okay, you know what? It looks like my 1 Satoshi transaction isn't going to confirm in the next block. So you know what? I'm going to bump it to 5. And then sort of keep an eye on the mempool or wait, half an hour, however much in a hurry they are. And in that way, sort of make sure that transaction confirms fast enough, but not overpay to make sure.
Exactly. Yeah.
So we've got 2 benefits already. One of the benefits is your transaction gets stuck. You want to get it unstuck. The second benefit is it allows for better fee markets.
Yep.
There's a third interesting benefit, and I think there are more if we want to get into the details. But one pretty obvious one is that with replaced by fee, you can make more efficient use of the Bitcoin blockchain. So for example, I'm paying you, Sjors, and then next I'm paying Ruben, who's not here today, but I'm also paying Ruben. And the way I could do that with replaced by fee is I send you one transaction first, and after that I decide that I want to send Ruben a transaction. So now I create a transaction that pays you both, and then include a good fee in that. So now instead of using 2 different transactions, I can use one transaction, which is more efficient block space wise.
Yeah, and exchanges can do this at a much larger scale, right? So they have lots of customers that they need to pay out, and so they create one transaction, and that's going to be the mempool for a while. And so every time another user withdraws coins, they just expand that transaction, and then whichever gets in the block, and the rest they'll just make a new transaction.
Exactly. They can sort of keep updating the transaction by including more and more recipients.
Yeah, which also, again, means more efficient use of the blockchain. So you get more value for your fee bytes.
So there are 3 pretty good benefits. One of them is getting transactions unstuck. The second one is allowing for a more effective fee market. And the third one is more block space efficiency.
Yeah, and I can mention a fourth one that will actually create a nice bridge to the downside, which is, let's say you make a 1 Satoshi per byte transaction to an exchange, and that exchange is called Mt. Gox, and you read on Twitter that, this is maybe not a very good exchange. So you're decide, okay, maybe I don't want to do this anymore. And so you can cancel a transaction because you can create a transaction with a higher fee that just goes back to you.
Right, yeah. So you're describing it as a benefit now. But like you said, this is what critics of replaced by fee would consider a detriment.
And it is, of course.
In a way. There aren't that many critics of RBF anymore, I think. But yeah, the detriment, the downside is that it allows for double spending if the recipient isn't going to wait for confirmations. So it's easier to double spend unconfirmed transactions with RBF.
Yeah, and this was, of course, a big discussion, say, in 2015, 2016, when what we're going to talk about was introduced. A lot of merchant applications would like to be able to just have an instant confirmation, essentially, but it wouldn't be confirmed. So that's inherently risky. But as I guess we'll explain, by default, if everybody played reasonably nice, it wasn't very risky. But of course, in Bitcoin, we think long-term, and we don't want to rely on something that just requires too much kumbaya.
Yeah, so that was indeed a big discussion on whether or not we should allow RBF in the protocol. I'm saying protocol, but to be clear, either way, it's not actually a consensus rule.
Yeah, so there's a difference between consensus, as in what is allowed inside of a block. So if you see a block with something in it that's not consensus compatible, you will not accept the block, and so the miners won't get their reward, and it's really bad.
It's just an invalid transaction, invalid block. Yep.
Yeah, but there's all sorts of rules that pertain to how the network works. Things that which transactions a node will relay or which ones it will reject. And those rules are, they're written in the code. So if you run the code as it comes, it'll do that. But there's not really any enforcement other than that. You can change the code or change the setting and it will behave differently.
Yeah, these are like peer-to-peer layer rules.
Yeah.
And importantly, this is also for miners. This is how they decide which transactions they include in blocks.
Yeah, but there it's even more important to realize that miners, of course, are very conscious of their revenue. So they will probably change something if the code does something that's not favorable for them economically, and they can get away with it. They will do it.
Right.
Presumably, if it's like not some edge case.
Yeah. So the reason it was sort of controversial at all in the first place is because it was going to be, the discussion was on whether or not RBF, replaced by fee, was to be included in Bitcoin Core. And most Bitcoin nodes on the network are Bitcoin Core. So if all Bitcoin Core nodes would, for example, reject replaced by fee transactions, then it would actually be very hard to get your replaced by fee transaction to a miner because nodes wouldn't relay it over the network.
Right, so you'd have to know who the miner is, or there'd have to be some nodes that would relay it anyway.
Yeah, or you'd have to be a miner or something like that, yeah. So by including replaced by fee in Bitcoin Core, that's how it would become a bit more easy to make an unconfirmed double spend.
Yes.
Okay, so that's sort of the argument against replaced by fee. Now let's debunk that argument, Sjors. Can we?
Go ahead.
Well, I will first mention. Do we?
Well, we at least brought up the point that we don't want to rely on people being nice and people using default settings.
Sure, that's the most obvious argument, that it's possible whether you like it or not. But like I said, whether it's included in Bitcoin Core kind of makes a difference on how easy it's going to be.
Yeah.
Okay. Well, I will mention, first of all, there's a thing called first seen safe replaced by fee, which people were discussing back in like 2015, 16.
Okay, how does that work?
The idea behind first seen safe replaced by fee is that you can only replace transactions if the recipients get at least the same amount of money.
Yes.
So that way, even an unconfirmed transaction is relatively safe under this context what we're talking about.
Right.
Because the transaction can be replaced, but only by adding even more recipients.
Yeah, but there's a huge problem with that, which is that the blockchain has no idea who the change address is. So normally what happens
Well, there's no change address at all.
Well, yeah, but that's already a problem with replaced by fee. But let's say I'm sending you 0.1 Bitcoin and I use a coin worth 0.2 Bitcoin.
Oh, sorry. There is a change address. There isn't a fee address. I was confused.
Exactly. So yeah, so that's good to remind the listener. There is no fee address. There is just how much I'm sending you and then how much I'm sending myself as change. And the difference between that is the fee.
Right.
The problem is if I send you 0.1 using a 0.2 coin, the change is going to be 0.1. And then if I want to raise the fee, well, normally what I would do is I would just lower the change amount. But with this rule that you just explained, you can't lower the change amount because the blockchain doesn't know. They might think I'm actually cheating the intended recipient rather than myself.
Right, that's a good point.
So that means you have to add another input every time you want to bump the transaction fee.
Yeah.
But that actually uses more block space, so it gets really expensive really fast.
Well, it could still work in the situation we described where an exchange adds new recipients in the payout address, for example.
No, they would have the same problem. That every time they add a new recipient, they would have to add a new input.
But that's fine.
Well, they'd have to have like a Sahara desert of dust to be able to keep doing that. Because if they want to pay 1,000 people, they need 1,000 inputs.
I guess you're right.
So it does not sound very practical.
Right.
I've never seen this proposal myself. I was not very active I was not active at all in Bitcoin Core when this played out. So maybe this argument has been mentioned, maybe not.
Maybe I hadn't heard it actually, but you're right. Then there is opt-in replaced by fee.
Okay.
This is what's actually in Bitcoin Core, right?
That's right.
So opt-in replaced by fee is replaced by fee. Well, what it means is the only way Bitcoin Core nodes will replace a transaction, if it includes a higher fee, is if the first transaction includes a special flag. So a sign that tells these nodes it's fine to replace this transaction if it has a higher fee.
Right. And so this is still a way to be nice, basically. But if you're a merchant and you're relying on this zero confirmation, if you see this flag, you know that this thing might disappear from under you. And Bitcoin Core nodes won't try to stop that.
Yeah, so the most practical sort of use case for this is if you are a merchant like Bitkassa in the Netherlands, I think they will accept an unconfirmed transaction. So if you're at a bar and you're buying a beer, they have a payment terminal and they will accept unconfirmed transactions. unless it has a RBF flag. Because in that case, they're just going to say, we're not sure enough that this transaction is not going to be replaced. So this is a rejection from us.
Yeah, and they have to do that in addition to checking the fee, because if you're sending a transaction with a very low fee, then it might also never get confirmed, and you have a lot of time to try and replace it. So it's still a can of worms, I think, as a merchant to do this. It's fine for small amounts, I guess, but then if it's fine for small amounts, why worry about RBF? But also, I guess the discussion now is not as critical as it was then, because now we have Lightning and we have pretty user-friendly wallets to the point where if you really want to accept something fast, Lightning is just much safer and better privacy too. So
definitely
back then that wasn't ready yet.
Lightning,
right. So
yeah, there are still some proponents of full RBF as well. I think Peter Toth is an obvious example, and I'm sure there are more. I probably would consider myself one.
I vaguely remember a mailing list post maybe a year ago where somebody suggested just turning on full RBF
right
at some point in the future. I think that didn't end up happening.
Right, yeah. His arguments, Peter Toth's arguments from... I don't know if these arguments have changed because it's been a couple of years since I wrote this article and spoke with him about this. But his argument was that the way these types of merchants can be relatively sure that a double spend isn't going to happen with an unconfirmed transaction is monitoring the network. So checking, having nodes on different parts of the network and see if there are any conflicting transactions going on. And this is in itself a problem that they feel the need to do this because, for one, it's bad for privacy, arguably. Well, that's his argument anyways, because these nodes now have a better idea of where transactions originated. And two, it's requiring resources from nodes on the network.
Yeah.
Because, these spying nodes or whatever you want to call them, these double spend checking nodes, they have to get blocks and transactions from different nodes on the network. So, they're sort of wasting resources.
Yeah. But
so it would be better, Peter Toth would argue, to just go for full RBF to make this kind of practices useless.
Yeah, but then those practices don't seem to be happening at a scale that's problematic, as far as I know. So I don't know whether you want to change it or not. The other thing is, now that everybody's running Lightning nodes, those nodes will have pretty much all of the same problems that you just described. They have to make sure that nobody's trying to close the channel on them, etc., does anything fancy. So I think we're already at the place where you really need to pay attention to what's happening in the mempool.
Right. Okay, so there is now a version of opt-in RBF in Bitcoin Core.
Yep.
And by the way, mentioning Peter Toth, I think he still maintains like a bunch of nodes that do full RBF.
Yeah, he used to have a separate release that was full RBF, and if you were sure that he wasn't trying to hack you, then I don't know if he released binaries or just code. It was just a one-line change.
Right. So, and the idea was there that people could still use full RBF if they want to. And I'm pretty sure that some miners actually do use full RBF.
Yeah.
Which makes sense because it's incentive compatible for them to do so. They make the most money if they do so. So anyways, but in Bitcoin Core, there is the opt-in RBF version. And I think you have some more details about what it actually does.
Yeah, so I guess it's fun to describe it in a little bit more detail. So given a transaction, like I said, I sent you money and I have some change back to myself. There are 5 rules that Bitcoin Core will check if I want to replace that transaction. And this has been the case since 0.12. So it's quite a while.
Like 5 years ago?
Something like that. Yeah.
Something like
2016.
that. Yeah.
So if a transaction spends one or more of the same inputs, right? That's the first condition. So remember,
that's what makes it RBF in the first place.
Yeah, because I can, I can spend twice. That's a bad idea. I could send you 0.1 Bitcoin and have a fee and then create a new transaction that uses different inputs. Then, of course, the blockchain will just mine both of them and I have a problem. So I have to replace the input. And if I do that, then first of all, I have to opt into this thing with the flag that we talked about. That's rule number 1. And then the rule is the replacement transaction may only include an unconfirmed input if that input was included in one of the original transactions, which is a kind of a roundabout way of saying the opposite. I can add new inputs to this new transaction because maybe I want to increase the fee, so I need some extra inputs, or I want to add other people. But this input has to be confirmed if it's a new one. And my guess is that this is just to prevent a can of worms where I have a transaction that is, unconfirmed, and I'm sending it across all the nodes, and it doesn't depend on any unconfirmed inputs. And now I bump it, but now it does depend on all sorts of unconfirmed inputs, and now I'm forcing everybody to figure out where those unconfirmed inputs are, and maybe they have a super low fee, and I guess it's too complicated to implement.
Right, yeah. I can see that.
Because, think about what this code looks like on the Bitcoin Core end. You have to write, you see this new transaction, and what are you going to do? Oh, now some of these dependencies are unconfirmed. I have to traverse that whole tree. I don't want to think about that. I only want to think about my descendants.
Yeah, it would basically allow for types of denial of service attacks, I guess, where you just...
Yeah, I think it's... my guess is it's both for denial of service, but also just to make the code easier to implement for anybody who writes this kind of node software. Then, rule number 3. The replacement transaction pays an absolute fee of at least the sum of the original transactions. Because you can replace, one transaction plus a bunch of its descendants, the things pending from that. But the absolute fee has to be the same. So if I paid...
Or higher.
Yeah, the same or higher. Exactly. Which also means that if I paid you and then you paid somebody else and I want to replace my transaction, then the transaction that you paid to somebody else, I have to at least pay the same fee that was in there. It's kind of a disincentive for me to reorg from under you. Because that's one of the annoying things with RBF, right? I'm paying you, you paying somebody else. Now I bump the fee. Oh, oops. The transaction you paid to somebody else is now gone.
Right.
And, well, I would have to really deliberately do that because I would have to increase the fee on my own transaction by enough that it also covers that transaction of yours that I just destroyed. So in practice, this wouldn't happen. We would either both agree to send a new transaction and somehow package them or not.
Yeah, there are probably very little, if any, sort of real-world examples where an RBF transaction would have a lower fee. So it's just to prevent weird attacks
but
and
it is an annoying
complications.
Rule, and maybe we'll get to it, but it's probably necessary. And then the fourth rule is it has to increase the fee rate by the minimum relay fee.
Sure.
So usually at least 1 Satoshi per byte, but if a mempool is full, then the minimum relay fee is going to be higher. So if the mempools are very full, then you cannot bump by just 1 Satoshi per byte. You may have to bump by 10 Satoshi per byte.
Right. This could differ from node to node. If they have different mempools for whatever reason, then they might have a different idea of what the minimum relay fee is. Yeah, so it might make its way through parts of the network, but not others. It's possible. Yeah,
this is a tricky bit, right? Because you know from your own node how much is in the mempool. And so you have to estimate what the minimum fee rate is that still goes into your mempool. But if you just start your node after stopping it, the mempool might be incomplete. And so you might be more optimistic about how low the fee increment can be. So it's kind of annoying. But it does make sense that you don't want people to spam the network and you want to keep...
Yep.
So, and the fifth rule is the number of original transactions to be replaced and their transcendent transactions will be evicted from mempool must not exceed a total of 100 transactions. So I guess the simple way to say is that if you do something convoluted that touches more than 100 transactions, it's not going to work.
Right.
And another caveat that I don't think is in these rules, but it is there, is that if you replace a transaction, it has to opt into it, right? Every one of its inputs has to opt into allowing this fee bump, but also for all the descendants, this has to be true. So if I send a transaction to you and you send to somebody else, but your transaction does not opt into RBF, then I can't replace my own.
Right.
And also I can opt out of RBF. I can bump the fee once and then I can say, now it's final. So I opt out in the last bump.
Oh, that's actually possible?
Yeah.
Right.
And this is probably also why there's so many problems. Because we could talk about problems.
Oh, there are problems?
There are problems.
Darn.
Especially, well, let's start with a simple problem that I don't think I've seen a solution for. Let's say I'm sending you a transaction, but I'm also sending Ruben a transaction. I think we mentioned that example.
Mm-hmm.
And those are two separate transactions. But now I think, oh my God, what if I combine those transactions? Because that would be more efficient.
It would be.
Yeah. But because maybe I can use fewer inputs in particular. Because I have one input that goes to you, and I have one input that goes to Ruben. And if I combine them, then they go to both of you.
Right.
So that saves me a number of bytes. But we talked about rule number 3, so I don't think we can do that.
Oh, because it has a lower absolute fee in that case?
Yeah.
Right. So there actually is a normal example where it would be handy.
Yeah, exactly. So because I've increased the fee rate, right? Because I have to increase the fee rate. But unless I double the fee rate, or I don't know what the factor is, because I've made the transaction smaller, the absolute fee is going to be lower. So generally merging 2 transactions is not, it's not going to work.
Right.
With the current RBF rules.
So yeah, the way to go then would be my solution to just not make 2 separate transactions, but the second one needs to already be the RBF one.
The downside of that one
needs to already combine the 2.
Yeah, the downside of that is you need to track a little bit more things of what's going on. Because in the example I gave you is either if one of them confirms, so if the one, if the one with the combined one, if it confirms, then you're done. If one of the original 2 confirms, then the combined one won't happen.
Mm-hmm.
So it's more clear which one you need to bump. But if you start combining things, you need to track, I guess, because one of those versions will confirm and you need to remember which ones to add. But you probably have to do something like that anyway. And a wallet can automate it.
Yeah.
And this is not really a consumer use case that often because, you might send more than one transaction per unit of time, but usually it'll probably be confirmed before you get to the next one.
Sure.
But for exchanges, this is relevant, but for exchanges, they can build the automatic tracking software.
Exactly.
So maybe this is a non-issue, but I just wanted to bring it up to illustrate the rule.
Mm-hmm.
And then there is transaction pinning, which is a problem with Lightning. And here, I think the simplest way to say is with Lightning, you have 2 parties that craft a transaction together, but they have to decide in advance what the fee is going to be.
Mm-hmm.
And that's annoying because fees can go all over the place. So when 2 Lightning nodes are connected, they are constantly sort of renegotiating those transactions and creating new ones just because they want to take into account the fee weather.
Yeah, well, what you mean, I think, is to be clear, in Lightning, you need to create a transaction with your channel partner, but then sometimes you'll only broadcast that transaction months later, while at the time of negotiating the transaction, that's when you're deciding on what the fee is going to be. While months later, maybe that fee is not going to be enough. That's the problem.
Yeah, but as your Lightning node is running, it's talking to the other side and it will renegotiate. So it's not too bad.
Okay.
Regardless, if the channel closes, maybe you don't reach each other and it might be a very unfavorable fee. So the idea here would be, wouldn't it be nice if you can agree on a very low fee, but you can RBF it yourself later? And so there was some complicated thing done with these Lightning transactions, as well as a rule in Bitcoin Core that would let you add extra outputs to it, and then each of the parties could RBF that if they wanted to.
Right, yep.
But the weakness in that story is that if I'm evil, I could basically add a transaction to RBF it, and it would say opt out of RBF, and the fee would be very low. Because we talked about this rule that all of the descendants have to opt into RBF. Does that make sense?
Can you repeat the last part?
So I'm doing this RBF transaction, but I'm opting out of it in that RBF transaction. I'm using a very low fee.
Yeah.
So now you want to bump that.
Oh, right. Yep. Got it.
You can't even add your own RBF anymore because one of the descendants is now opting out. And there's very shenanigans like that. Like you could add a chain of 99 transactions to it. So you violate the 100 maximum rule. You add 99 transactions with a super low fee. Now the other side cannot add number 100 or 101.
Right.
And all sorts of annoying shenanigans that if you go to a Lightning developer mailing list, it is full of this sort of pure headache. And I don't think that just going for a full RBF would really solve that, because the other problem we talked about in another episode is just package relay in general. Like, what do you do with these if somebody wants to replace a chain of 100 transactions?
Mm-hmm.
Yeah, that kind of worm, I'm just going to leave it open. Just saying that this is, every now and then on the mailing list, you'll see threads and people proposing different solutions and then people explaining why that doesn't work.
Yeah. Okay, well, that was getting very into the weeds. Let's get back to the beginning. What actually happened with this double spend concretely?
Back to our amazing adventure that made it all the way to Bloomberg and crashed the market by 7%.
Allegedly, maybe.
No, I don't actually believe in astrology. So basically, What happened is forkmonitor.info is a site that I also work on by BitMEX Research.
Yeah.
Detected 2 blocks at the same height. This is called a stale block, or at least one of them is going to be stale.
One of them is definitely going to be stale because, for obvious reasons.
Yeah, because other miners will see 2 blocks, and then there's some heuristics, like just build on the first one you saw, for example. Also, nodes will do that. They will, if all things equal, they'll pick the first one they saw.
Mm-hmm.
And at some point, miners will build on one side or the other, and that's going to be the final blockchain. But now what happens if in one of those blocks is a transaction that sends money to you, and in the other block is the same input, but it goes to me? Now, that will be a double spend.
Right.
Now, in this case, what seemed to be happening is that there was a fee. Somebody did an RBF fee bump, basically.
Mm-hmm.
But the winning, like the higher fee ended up in the shortest chain and the lower fee ended up in the longest chain.
Mm-hmm.
And this probably wasn't any nefarious thing. It's just that those transactions and the fee bumps are moving around the mempools all over the Bitcoin network. And you find a block just before you see the increased fee and you miss it.
Yeah, so that's probably what happened is that there was one fee and then there was a replacement fee. And while the replacement fee was still making its way over the network and reached one miner that mined the block, it hadn't yet reached another miner that also mined the block at the same time. So now there were conflicting transactions in the 2 blocks.
Right. And if I remember correctly, this particular transaction also had an up return script. So it was probably some sort of protocol, like that's doing some sort of token thing. And the up return script was also changing. So that's why it was marked as a double spend and not as a fee bump. Because I wrote the detection code for that, and one of the rules was like, if the fee changes by a little bit, I'll consider it a fee bump, with or without the RBF flag, because maybe people use it or they don't. But if something weird changes, then it just says, just manually investigate, this might be double spend. And that, crashed the market.
Right.
But there was nothing going on.
Yeah, it resolved exactly like you would expect it to resolve, exactly like how Bitcoin is designed.
Alright, anything else then?
No.
Alright, thank you for listening to the Wirdum Sjorsnado.
There you go.